Okay, I'm going to look at one additional example here. This is an example. This is actually the mean value theorem, but it's a special subset of the mean value theorem called Rolle's theorem. It's named after a French mathematician. The name may actually be pronounced Rolle, but traditionally in the United States it's pronounced Rolle's theorem, so I'm going to call it Rolle's theorem, even though somebody French might pronounce it slightly differently. Rolle's theorem is actually the mean value theorem. Okay, so the AP exam will never actually mention Rolle's theorem by name, but you could run into situations where you'll see Rolle's theorem. Okay, here's the situation that you're normally going to see for Rolle's theorem. Rolle's theorem applies to cases in which the function crosses the x-axis and then changes direction and comes back to the x-axis. Okay, and on that interval, and for this particular function here, negative x squared plus 10x plus 7x plus 10, this function crosses the x-axis at 2 and 5, so that's the interval we're looking at. If you find the average rate of change here, if you found f of 5 minus f of 2, and then divided by 5 minus 2, I believe you're going to find out that f of 5 works out to be 20, and f of 2 also works out to be 20. When you're dividing by 3, you end up getting an average rate of change of 0. What does this mean? Well, I think it's pretty common sense. If you found the slope of the secant segment there, the slope would be 0. Okay? So what that guarantees is that the instantaneous rate of change of the function will also equal 0 somewhere in the interval, which means you're just going to get a tangent line that's horizontal because the secant line slope is also horizontal. Okay? By the way, some books do a little bit of a variation on this. Forrester's book specifies that the function has to have a situation where f of a is equal to 0 and f of b is equal to 0 for this to work. You can see there it's crossing the x-axis in both places. Some books change it just slightly. Some books say that Rolle's theorem applies anywhere where the two functional values are the same. So, let's say that I have a functional value at 5, and f of a is equal to 5, and f of b is also equal to 5. Well, if you find the average rate of change there, it's still going to be 0, and that's going to guarantee that if the function meets the requirements of the mean value theorem, that is to say it's continuous and it's differentiable, so it's a smooth curve, that you're going to have a horizontal tangent at 0. Okay, again, AP exam never actually mentions Rolle's theorem, so the point is, if you see a situation where the graph crosses the x-axis, or if the starting and ending functional values are the same, you should be guaranteed that your function is going to have a horizontal tangent, which, by the way, means that your function is going to change direction somewhere in that interval. So if your function has zeros at two different places and it's continuous and differentiable, that really guarantees that your function will have a relative maximum or relative minimum somewhere in that interval. If you want to think about applications of this, it would be useful. Okay. So anyway, that's the basic idea of Rolle's theorem. You're just trying to figure out where the derivative is equal to 0. So the work here is exactly the same as what it would normally be. I already found the average rate of change to be 0. So we're setting f of b minus f of a equal to the derivative at some value of c. Okay? Well, we already found the average rate of change to be 0. I'm just setting b equal to the derivative there, which is negative 2x plus 7. You get negative 7 equals negative 2x, and x is going to be 7 halves, which of course is 3.5 if you want to write it as a decimal. I like 7 halves actually. But what that says is that 3.5, which by the way in this particular graph is exactly halfway between 2 and 5, you're going to have that point where the slope of that tangent line is horizontal. Okay? Forrester's going to have you do quite a few problems where you just see whether or not the mean value theorem or Rolle's theorem applies. In most of these cases, you're looking for two things. First of all, is the function continuous and differentiable? If it's not, mean value theorem and Rolle's theorem might not necessarily apply. Number two, if it's Rolle's theorem, you need to check and see, is the average rate of change 0? The average rate of change is 0. Rolle's theorem isn't going to apply, and could still be a mean value theorem problem, but it's not going to specifically be Rolle's theorem. So again, not really anything different, just kind of a variation on a concept that we already understood.